Welcome to Learn Commerce PU online classes. Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to our second PU Computer Science online classes. In last class, we studied some important concept in Boolean Algebra about NOT operator, AND operator and also the OR operator, and also some of the principle of the duality. We know that some rules in principle of the duality, the three important rules are there: changing each or changing zero or sign to an AND sign, and changing AND sign to an OR sign, and also changing by 0 and to 1 and 1 to 0. So this is the important rule of the principle of duality, and we also know that what's the definition. So this is very important principle, and this principle states that this starting with a Boolean relation, another Boolean relation can be derived. And after knowing some important concept, now let's the next concept in our Boolean algebra, basic theorems of the Boolean algebra. And such basic theorems of Boolean algebra is also called as the proof by perfect induction. Now what about the proof by perfect induction? So we can say, or the definition of the proof by perfect induction, it is a method, and in this method we are going to prove the Boolean theorems. And how we are going to prove the Boolean theorems? By substituting all possible value of the variables. And again I am going to repeat the definition of proof by perfect induction or the basic theorems of the Boolean algebra. It is a method, and in this method we proving the Boolean theorems, and the Boolean theorems going to prove by substituting all possible value of the variables. So some of the rules are that the first rule of the Boolean theorems, properties of 0 and 1. So in property of 0 and 1, some important we need to prove the first law or the first property of 0 and 1, that is 0 plus x is equal to x. Second, 1 plus x is equal to 1. Third one, 0 and x is equal to 0. Fourth one, 1 and x is equal to x. Now let's, because everything we are going to prove one after the another, and while proving we should get the value as x. And maybe while going to prove the second one, 1 plus x is equal to 1, should get the answer, the left hand side should equal to the right hand side, or maybe 0 and x left hand side, that is equal to 0, call as the right hand side. So we need to prove. And before going to go how to prove all those, now let's the symbol by using the 0 plus x or the property of 0 and 1. So 0 plus x is equal to x. Now in this proving, first of all I am going to draw the first one, the 0. We know that in between 0 plus x, which operator is that? The operator, or we can say plus symbol, correct now? So we need to use the symbol as the OR operator. So 0 or x is equal to x. Clear this point here? Now the second thing, 1 plus, that is we need to draw OR operator, or plus x is equal to 1, that is the result, should get it. 1 plus x is equal to 1, 0 plus x is equal to x. Now the third thing, 0 and x is equal to 0. So we know that in between 0, x, one symbol is this symbol is the dot operator, and it is equal to the logical multiplication, and we using in our AND gate operator, okay, AND gate. So 0 and x, the value or the result that is equal to the 0 should get it. And later next one, the last one, 1 and x is equal to x. So 1 and x, the value is equal to x. Now we know that because whatever the property of 0 and 1, just I completed, and by using the property I completed the symbol. So all showing the symbol of the 0 plus x is equal to x, 1 plus x is equal to 1, 0 and x is equal to 0, 1 and x is equal to x. Now we are going to prove everything. So first of all I am going to select 0 plus x is equal to x. So I already completed, I already written 0 plus x is equal to x. Now first thing, in proving, first of all I assuming some value for the x. So here we can say that the proof, if x value is equal to 0, okay, I used the value to the x, the value as the 0. Now I am going to consider, we know that this one is called as the left hand side is equal to right hand side. Now in left hand side, which value is that? 0 plus x. In right hand side, the value is the x. We should get the value. We need to equal the value. When if both the value are equal, then only we can say that such property is going to prove. Okay. So 0 plus x, left hand side, x, that is equal to the right hand side. Now I am just started the proving of 0 plus x is equal to x. Now first of all, before going to prove, I am assuming or initializing some value for the x. The value is the, if x value is equal to 0. And later in next line, the left hand side. In left hand side, which value is that? In left hand side, I selected, or we can say I already written value 0 plus x. So just only I am going to write the value considering the value from the left hand side, that is the value 0 plus x. And after the 0 plus x, in next column, we know that the 0 value as it is, we need to write plus sign after the 0, the plus sign, and later x. Now what's the value I provided to the x? The x value is equal to the 0. Now instead of the x, I am using the value for the 0. Clear this point here? So x value, I am taking the value for x as the 0. I already provided the value to the x. Now we know that why, because plus, the plus is called as the OR relation, by OR relation. Clear this point? Maybe dot is there, we need to change to the by and relation, but plus symbol is that because of, we need to say, we need to write as the by OR relation. Okay. And later we know that when you are going to add maybe the value 0 plus 0, always the value is the 0 only. Okay. So now just we got the value as the 0. Now in this case we can say that the 0 is equal to x. Is it? Why? Because what's the value of the x? The x value is the 0. So now just only still here we don't know whether it is going to prove or not, but also in starting step, if I provided the value for the x, we know that the x value is equal to 0. So what's the value we added to the variable x here, such the value will get as the answer or the result. Okay. So now in starting step, the 0 value is equal to x. That means we proved the right hand side just by using the x value as the 0. And after completing the value to x as 0, now I am changing the value, I am using the value for x as 1. Okay. Now in our, when you are using or when you are writing the value of x as 1, now we are going to prove, is it true or is it proving or not. Clear this one? Now if x value is equal to 1, clear? X value is equal to 1, and we know that in left hand side which value is there, again I am going to take, but in this concept I am using the x value as the 1. Why? Because how you know why I am going to change the x value as the 1? Why? Because here I am using the x value as the 1. Now the value of the x is changed, okay, just only to check whether it's going to prove or not 0 plus x value is equal to x or not, or in simple way left hand side is equal to the right hand side. Now in left hand side the value is the 0 plus x. So again I am going to write the value as the 0 plus x here, and later next one after that 0 as it is plus, and we know that the x value, what's the value? The value is the 1. So in place of the x I am using the value as the 1. Now which value I completed? 0 plus x. When you are going to add 0 plus x, what's the answer will get? The answer is 1 only, is it? So we can say that now when you are using the x value as the 0, we'll get the answer as 0, okay, and when you are changing the x value as 1, what's the answer will get? The answer is also 1. Clear this point here? So we can say that is equal to x, correct? Now is equal to x. Here just only 0 is equal to x. Why? Because here the 0 value, x value is equal to 0. So we can say that 0 is equal to x, like our right hand side, okay, and when you are going to change the x value as 1, then also we'll get the answer as the 1. That means what's the value we using for x, such value only will get as the answer, okay, yeah, and 0 plus 1 is equal to 1, that is equal to our x, and how we got the answer? By using our plus sign. The plus sign is equal to by or relations, that is equal to the right hand side. Clear this point here? So like that we are going to prove. So we can say that the first thing, that is 0 plus x is equal to x, or the left hand side is equal to the right hand side. So therefore here the left hand side is equal to the right hand side, and thus for every value of x, that is 0 plus x is equal to x always, correct? No, because when you are using x value as 0, what's the answer will get? The answer is the 0. When you are using x value as 1, what's the answer? The answer is equal to 1. So we can say that thus 0 plus x, correct? No, here thus for every value of x is equal to the 0 plus x, that is equal to x always. Now let's, by using our truth table, we are going to prove is it the value is going to prove or not. So we already got the answer whether it's proving or not. Here only we get the answer about our x value is equal to 0 and x value is equal to 1. Also in final touch we are going to prove by using the truth table, and in our truth table I am going to use 3 columns. In the first column I am going to take as the 0, and the second column is the x, and third column shows the result, that is equal to 0 plus x, okay, and later we know that this 0 value as it is, so 0 value not going to change, so 0 only I am using. Why? Because it is the rules, the property of 0 and 1, okay, in Boolean algebra. So 0, and just in starting step what's the x value I used? The x value is equal to 0. So the same value I used in the truth table, and when we know that when you are going to add these two value, 0 plus x value is the 0, 0 plus 0, what's the result will get? The result is the 0 only, 0 plus 0, the result is the 0, and later next one is the as it is, in place of the 0 only we need to write, but the x value going to change to the 1, correct? No, why? Because just by using the x value is equal to 1 and also the x value is equal to 0, we need to show, we need to use by using both the values, and later we are going to check whether it's going to prove the left hand side is equal to the right hand side. And when you are using the value of x as 1, then 0 plus 1, what's the value? 0 plus 1, the value is always 1 only, okay. So this is the result. So we can say that the truth table for the above expression, the above expression is the 0 plus x is equal to x, or the 0 x result, that is equal to 0 plus x. So the truth table for the above expression is given in the table, and here R signifies the output. Clear this point here? The R signifies the output. Depend on the x value, it going to give the answer. If the x value is equal to 0, the result is also 0. If x value is equal to 1, the result is also 1. So we can prove that the 0 plus x is equal to x. The left hand side is equal to right hand side. Clear this point here? What about just only, first of all I selected the option A. In option A, 0 plus x is equal to x. Later words I completed the symbol for the 0 plus x, 0 or x is equal to x, and later by using the value left hand side value and also by using right hand side value I am going to prove, I am going to check whether both value are equal or not, and while going to prove I used the value for the x as the 0 as well as x value as the 1, and later we completed the truth table. Clear this point here? And we can finally we can say that the R signifies the result or the output of the truth table. 0 plus x is equal to x. Now let's the second thing. The second one is the 1 plus x is equal to 1. We know the truth table symbol. The symbol is the 1 or x is equal to 1. When you are going to add 1, maybe the x value as 1, the result is 1 only. 1 plus 1, result is 1. Maybe the x value as 0, 1 plus 0, the result is always 1 only. Clear this point? Now we are going to prove whether is it true or not, whether it proving or not. The value 1 plus x is equal to 1. Now this is our second option. Now second thing, 1 plus x is equal to 1. Proof, if x value is equal to 0, first of all I am going to use some value for the x and x value as the 0. Now left hand side, in left hand side which value is that? In left hand side the value is the 1 plus x, okay, and right hand side value is the 1. Clear this point? This is the left hand side and this value is the right hand side. Now I am going to prove whether left hand side value is equal to right hand side. Left hand side 1 plus x, in right hand side which value? The value is the 1. So before going to prove, I am going to use some value for or considering some value for the x as 0 as well as the x value as 1. So first of all left hand side, x value as the 0. So in left hand side we know that 1 plus x is there. So 1 plus x, 1 plus, now what's the value of the x? The x value is the 0. So 1 plus 0, when you are going to add 1 plus 0, the value is the 1 only. Clear this point here? 0 plus 1, 1 only. 1 plus 0, the value is 1. So what's the answer? See here, the left hand side 1 plus x, right hand side 1. Now just only we proved about the value as the 1. So 1 value is equal to x value. Clear this point here? So we can say that the 1 value is equal to x value, and have we got such relation by using our OR relations. By OR relation, that is equal to the 1 value is equal to right hand side. Clear this point here? The 1 value is equal to right hand side, and later words, now just the value of the x. Now in our starting step I used the value of x as 0. Now such value I am using, I am changing the value of the x to 1. So if x value is equal to 1, left hand side 1 plus x, correct? No, 1 plus x. Now we know that 1 as it is plus also the same thing we need to write. Now just we change the value of the x. What's the value of the x? The x value is our 1. So 1 plus 1. Now if you are going to add 1 plus 1, the always the value is the 1 only. Clear this point here? So in our starting step, when you are going to add 1 plus 0, the value will get as the 1, and when you are changing the value of the x as 1 here, then also we'll get the result as the 1 only, that is equal to x. So in this way we can say that how we got the value by using the relation like our or relations. Okay, kya? The or relations here. So that is equal to the right hand side. So therefore the left hand side is equal to right hand side, hence it is proved. Clear this point? So why? Because see here 1 plus x is equal to 1. We are going to check the value of the left hand side is equal to right hand side here. So left hand side value is equal to right hand side, hence it is going to prove, or it is proved, we can say that. Or finally we can say about the truth table, or before going to check the truth table, thus every value of x, the value of x is the 1 plus x is equal to 1, okay, always here. So every value of the x is 1 plus x is equal to 1 always. And in our truth table, first of all the 1, second heading is the second column name is the x, and result shows 1 plus x. The result that is equal to 1 plus x. We know that the 1 value as it is we need to take, and in starting step what's the value we added to the x? The value is the 0, and when you are going to add 1 plus 0, the result is the 1. Clear this part? The result is the 1. Here only we got the value as the 1. Clear in this case? And later next one, now let's by using the x value as 1. So 1 as it is, it's there in property of 0 and 1, and later next one x value also. First of all the value of x is the 0, and later words after the proof we got the answer. When you are going to add 1 plus 0, the result is equal to 1 plus x, the value is the 1 only. And later next one, when you are going to add the x value as the 1, when you are adding 1 plus 1, always the value is the 1 only. So the truth table, so this is called as the truth table of the 1 plus x is equal to 1. So the truth table for the above expression is given in the table, and here the R signifies the output, or that is called as the result. So clear this point here. So we can say that we already proved to 0 plus x is equal to x, as well as 1 plus x is equal to 1. Thank you.
Don't forget to like our video and subscribe our YouTube channel for all the updates.